just to be sure. Okay, let us begin with the general instruction for Openfoam. Okay, so if you open up the Google Classroom, okay, you will have direct access to the main documentation. So if you open up this one, okay, you have all of the, you can see all of the learning roadmap. So I suggest that you install Ubuntu Linux via WSL. Okay, follow the instruction here one by one. Okay, and then for using Openfoam, you cannot avoid dealing with command line interface like this. Okay, command line interface like this one. Okay, you have to type some command. Okay, but basically, say if I open up my file explorer, okay, it is something similar to this one. Okay, say for example, okay, now I am at home, home location here. Okay, so let's say I want to enter downloads. Okay, I can press CD, meaning change directory, downloads. Okay, so I'm entering this download directory. Okay, next I can also go up like this one, CD double dot means the parent folder. Okay, now I am in the home folder. Okay, so assume like whenever you click and double click the button, it is similar to CD. Okay, change directory command. Okay, so in order to properly use Openfoam, okay, you need to be familiar with the command. Okay, command to run things. Okay, so once you install Ubuntu, you on Windows, when you open up Ubuntu, you will be presented with this command line interface. And in order to manage, okay, you want to know the command, you can follow this tutorial. Okay, there's some important commands. Not everything. Okay, but if you see these slides, okay, it will walk you through some important commands. Let's say cwd, current directory. Okay, pwd. What's pwd? It is something to show you where is your current location. Let's say if I press this button, okay, I am currently inside home directory and then my user directory. Okay, if I press pwd here, means it is print working directory. This command for printing working directory. If I press enter, it will give you current location. Okay, all right. So go through this tutorial. How to list file, ls. If I press ls and type ls and press enter, it will give me the list of folders and files, just like your explorer, file explorer. Okay, and then how to copy paste file, how to list file, how to move file, and how to copy files and so on. All right. Okay, next, okay, I will show you this one for undergraduate course. I will go through the basics, but for master course, I expect that you have spent some time, okay, to work it out yourself. Okay, but if you have problem, I am ready to help. Okay, and then installation of Openfoam. Okay, follow the official, okay, official instruction. Okay, just for me, just copy one by one. This one, copy and paste in the and then press enter and then give password. Okay, one by one, and then you can install the Openfoam lah. And follow these simple steps. Okay, run the command one by one. If you have problem, if there are errors, you can send it to me for facilitation. Okay, next on what? And now here installation of Openfoam. I hope everyone can must finish it by this week. Okay, including the tutorial. And then we have like 3 weeks left. And then okay, install ParaView to display file. Okay, now we officially begin with the driven cavity flow. Okay, and actually there is no need for me to go through one by one, but to facilitate you, I will do it anyway. Okay. Okay, there are some comprehensive tutorials. Okay, getting started. Okay, for Windows users. Okay, and then okay, lead driven cavity flow. Okay, this is a must do tutorial so that you will work. This tutorial will walk you through all of the features of Openfoam, from setting up the case, what utilities you have, and up until setting up the mesh, up until displaying the results. Okay, I would say that this is a very simple case physically, but if you do this one by one, if you do these steps, each of these steps one by one, you know every essential functionality of Openfoam. Okay, how to display. And then when we move to more complex tutorials, we are not getting bogged down with difficulty to where to click this one, where to display the result, where to create the mesh. Okay, so I hope everyone can do all of these basic tutorials. Okay, these specific tutorials. Okay, next on the I think we begin. Okay, so in the group, I have shared with you the slides. So let me open up the slide. Short course Openfoam. I'm using some old slides. Okay. Okay, you can stop me if you have a question. If you from this slide, you can go through the basics of lead driven cavity and jump straight to the half resistance. Okay. Okay, before anything, I will briefly explain to you what is Openfoam. Okay, so Openfoam is open source fit operation and manipulation. So open and then FOAM. Basically, this is a library to solve general field problem. Okay, and C++, this is written in C++. Okay, to solve partial differential equation. Okay, originally developed by Henry Weller and Wove Yasa from Imperial during that time in Imperial College London. Okay, then if you Google Openfoam, you can see main 3 version because it's open source. There are many versions of it, but the main version you can find in openfoam.com. Okay, so this one is maintained by a company called ESI Group, and then Openfoam Foundation.org. Okay, and Foam Extend. This one developed by Jasa. So for COM, I prefer to use this one because it is maintained by a company, and looks like the features are more. Openfoam.org is you can use that as well. There are some features not available in openfoam.com, and Foam Extend is more open. So many groups, many research group customize the Openfoam and submit to the Foam Extend. So you can find much more features there, but because it is not official, you might encounter some problems. Okay. So it is packaged with utility solver, pre-processing utilities, and post-processing utilities. And the license is GNU, meaning if you make some customization on the code, you need to release the source code openly. Okay, you cannot repackage it and release it as closed source. And you can find the use of Openfoam in industries, academic research, and research labs. Okay, because it is free. If you use a commercial CRV package, okay, you can buy the licensing, the yearly licensing for the software for academic purpose allows you to buy high-end computer every year, 2 high-end computer every year. And for commercial, perhaps 10 computers every year. So that's why some group use this tool. Okay, so the features, there are many tools: modeling, thermophysical, transport, but for our concern of use, we are going to use it for its features for multi-phase flows and dynamic mesh. Okay, so multi-phase flow, because our problem consists of free surface, free surface, ocean water, ocean wave, and so on. And because of the wave, of course you will have moving body, so we need to use dynamic mesh. Okay, and in general, CFD, general CFD workflow will have pre-processing step, and then the solution step, and post-processing step. Okay, and the standard Openfoam package will give you, of course, the solver itself. This one is for steady flow single phase. This one is steady flow single phase, unsteady flow single phase. Interform is for multi-phase flow, with free surface. And then it also includes a mesh generator, own mesh generator, mesh converter. If you create your mesh using other software, let's say you create yourself your mesh using ANSYS, using Fluent, maybe Star CCM, you can use the provided mesh converter. And then of course you should set up your model. What is the physical model? Multi-phase, single phase, turbulence properties, initial and boundary conditions, and solution control, and so on. And say you can use external 3D modeler and then supply it in the mesh generator. You can use external measure like CF mesh and G mesh, Gambit from ANSYS, and so on. And once you get the results, once you solve the problem, you can use another tool, which is ParaView, to display the results, to visualize the result, to analyze the results. And on the architecture and numerics, so the discretization, this is a bit technical, quite technical. Find a volume method with collocated polyhedral unstructured meshes, and second order accuracy in space and time. And steady and transient solvers are available. You have a lot of methods, segregated solution methods, and you can solve it in high performance computer with massive parallelism. Let's say you want to solve your problem on 100 or 1000 number of computing cores. You can use it. Next on how components are implemented in library structure. So you can become an expert in Openfoam, and perhaps you see the need to have your own customized solver. You can do that, okay, because the code are there. Okay, so why people use Openfoam? Although you have commercial CFD software available, we have ANSYS, we have Star CCM, okay, we have Shipflow and so on. Okay, because of what? First, it is free. Okay, commercial CFD applications are expensive. Okay, for commercial, it can be hundreds of thousands of ringgit per commercial license. Okay, depending on the course you want to use, number of courses you want to use. Okay, but because it is free, there is no native graphical user interface. Okay, you have to use common interface to operate Openfoam by default. Of course, there are GUI available to manage with it, and users have to directly edit case configuration in human readable plain text format. Okay, you can see it later. And while being tedious and prone to errors, this allows automation of large number of fronts using user-defined shell scripts. Okay. Okay, nowadays we are talking about AI, right? You want to train surrogate model using artificial intelligence. So because you can automate, you can do the run using scripting, so you can automate large number of fronts. And again, you have third-party graphical user interface, and official documentation may not be complete, but you can find scattered around the internet. And source code is accessible, so you can customize yourself. And it is free. Illustration on the number of parallel computing process makes Openfoam typically available in large HPC clusters. So if you master Openfoam, you can find your relevance in high-end research center, okay, that deal with flows and so on. Okay, and let us see. There are some options for GUI for Openfoam. Okay, graphical user interface. Okay, we have no official GUI, but you can find many available online, but this one I think no longer available. And okay, for example, this one, okay, CAE, Cloud CAE, basically they package the interface, okay, browser interface, so that you can operate in. But as far as I know, their solver for CFD, okay, they use Openfoam to solve the problem. Okay, behind the scene they use Openfoam. Okay, and for my case, I developed my own GUI for managing the run, as you can see last week. All right. Okay, installation. You cannot follow this one as well, but this one is quite outdated, so follow the main instruction that I have shared. Okay, and the first tutorial, okay, you can go through this tutorial for brief introduction to a brief tutorial description, okay, for lead-driven cavity and for power resistance. Okay, but I suggest that for lead-driven cavity you can use this tutorial. This one is more complete. Okay, but anyway, the most complete will be in the official documentation for the tutorial. Okay. Okay, so first we look into the introduction to Openfoam, lead-driven cavity. Okay, the very first case that everyone must do. Okay, so let me